So if we have this integral, and to make it possible how to solve it, we are going to multiply by 1. This is a multiplication of identity property, and instead of 1, we are multiplying ex times ex over ex. So both sides up and down we are multiplying by ex over ex. So, but just let me write this one here in this form. So this integral is going to be in x. So we are multiplying both sides up and down with the ex. And here is the ex over e into x plus 2 in ex plus 3. And now we are going to substitute. We are going to substitute the ex is equal with the u. If we are taking differential both sides, ex dx is going to be equal with du. And this integral is going to look in this form. Instead ex dx, I am plugging in du. And whenever I have ex, I am going to plug in u, and here is a u squared plus 2u plus 3. But now I am going to make another substitution. Instead of the u squared plus 2u, so I am taking this expression, u squared plus 2u plus 3, and I am applying here square, completing square, just in this part here. And here is a u squared plus 2u plus 1 minus 1 plus 3. And now just this part here is going to be u plus 1 square. And minus 1 plus 3 is a plus 2. So this substitution I'm going to substitute now. This expression I'm going to substitute instead of this quadratic expression. And the integral is going to look this way. U times u plus 1 square plus 2. That's how it's going to look. But now I'm going to make another substitution. And the another substitution is going to be this way. Instead of u plus 1, I'm going to use v. And now u, if I am subtracting both sides by 1, u is going to be v minus 1. And if I'm taking differential both sides, du is going to be equal to the dv. And now the I is going to be integral. Instead of du, I plug in dv. Whenever I have u, I can plug in v minus 1. V minus 1. And instead of u plus 1, I'm plugging v. And this one is a v squared plus 2. So that's what we have here. And this fraction I can write in a partial fraction. I can write as a dv here over v minus 1 and v squared plus 2. I can write in this form as an integral a divided by v minus 1 dv plus I can write bv plus c divided by v squared plus 2 times dv. I can write this way. So this is a partial fraction, and in previous video I solved how we can find the a, b, c, and how we can expand. But here I'm taking a shortcut, so I'm not expanding here in this one, and instead of the a is going to be 1 over 3. And this one is a dv over v minus 1. But you can watch in the previous videos, so you can see how we can work with the partial fraction, how we can decompose. And now is a minus 1 over 3 integral v dv over v squared plus 2, and minus 1 over 3 is dv over v squared plus 2. So now if you take in just a dv over v, so this integral, let's say this is I1, this is I2, and this is I3. And if we take in just integral I1 here, and if we are solving just this part, dv over v minus 1, this is elementary integral, and this is going to be equal with the ln v minus 1 plus c1. And we are taking I2 here, this integral is going to be, so v dv is v squared plus 2. So this one we can substitute a little bit. Instead of the v squared plus 2, we can take a t. And if we are taking the differential both sides. So 2v dv is going to be dt. But if we are dividing everything by 2, v dv can write 1 over 2 dt. And now whenever I have v dv, I can write 1 over 2 dt. So this one can be in this form, 1 over 2 dt. And v squared plus 2 is equal to t. So as we see here, in this one, as we see, dt over t is ln t, so it's elementary integral. So this one can be 1 over 2 ln t. In fact, this is 1 over 2 ln, instead of the t is v squared plus 2. v squared plus 2 plus c2. And the third integral, I3, which was dv over v squared plus 2. So this is elementary integral, and this one is 1 over square root of 2 arcus tangent, or we can write inverse tangent, minus 1. So is v divided by square root of 2 plus c3. And now all these integrals we are plugging here in this integral here. But don't forget I. So those I'm writing I is just because to simplify a little bit, to look a little bit, to go the process smoothly. I1, but here is 1 over 3. And we have ln v minus 1. So it's ln v minus 1. And the other one is minus 1 over 3 I2. So that's what we have, minus 1 over 3 I2. Minus 1 over 3. And I2 we already have this integral here. So is 1 over 2 is ln and v squared plus 2. v squared plus 2. And the last one is I3, but is a minus 1 over 3 and is a time 1 over square root of 2 inverse tangent of v divided by square root of 2, and c1 plus c2 plus c3 we can combine all of them and we can write with the c plus c, the constant c. But don't forget v was equal with when u was v minus 1 and v was with u plus 1, and if we are doing those in the u, we can convert the substitution. I is going to be equal with 1 over 3 ln, instead of v minus 1 we can plug in u, and here is minus 1 over 3 time 1 over 2, this is ln. Instead of the v square, instead of the v here, I can write u plus 1 instead of the v. So we already see there is u plus 1 square, and here is a plus 2. So here is this one here, and this is a minus 1 over 3, and here is 1 over square root of 2 tangent, inverse tangent or arcus tangent, and v is u minus 1. u minus 1 is divided by square root of 2. Instead, in fact, v is u plus 1. So just let me make sure one more time. So v is u plus 1. Okay. And now, but u was in x. So the integral I is equal with 1 over 3 ln in x. This one here, but this one minus 1 over 3 time 1 over 2 is a minus 1 over 6. This I can write 1 over 6. Here is a ln, and instead of the u is in x plus 1, but here is a square. Is a square plus 2. And the other one is a minus 1 over 3 is a time 1 over square root of 2 is inverse tangent, or let me write arcus tangent. I can write this form too. And u plus 1 is in x plus 1 divided by square root of 2, and everything here is a plus c. So this is the final result. So just let me look how it looks. So this is the final result. So this is the final result.